Okay, good morning everyone. I hope everyone is awake. So today we're going to talk about Crossplane for platform engineers. I'm Tobias, I'm solutions architect at Abound, and I'm here today with Yury.
Hey everyone, I'm Yury from Abound. Abound is a company behind Crossplane, the original creators of the project. And maybe quick show of hands, who used Crossplane before? And who used Crossplane in production? That sounds pretty good. Thank you for the feedback. And Tobias, please kick us off.
So we have a lot of material to cover, so I'm trying to be very brief and very quick. So before we talk about building a platform, like let's say why are we trying to build a platform and what a platform is even. So I brought this real-world picture of a platform. Here it's about drilling for oil. In our context, it's for delivering and building software, but there's a few fundamental concepts which are essentially the same. So it's a structure building stability and support, and it also provides all the tools which we need, and the unification and access control and all the nice things. So by building this platform, it helps us to increase velocity and throughput. We have a single source of truth for both developers and operators. We can achieve reliability and resilience by making best practices right into the software development lifecycle. And we can also reach easily maintain security and observability by automating otherwise tedious practices right under the hood. So we don't want to start from scratch, and we don't want to reinvent the wheel. That's why we start with Kubernetes as a foundation. And why do we do so? Because it's already a de facto standard for deploying containerized workloads. It's declarative and extendable, and at its core, it has this mechanism of a controller that reconciles an actual state with a desired state. And if you remember the picture before, like the world around us is constantly moving, and that's exactly what we need to achieve stability. So it's already a mature and battle-tested platform. It provides this access control we're looking for. It integrates with GitOps tools, and it's designed to auto-heal. Also, we can use it for infrastructure or everything else that exposes an API, which it doesn't know by design, but it's still a perfect starting point for building our platform. That's where we enter Crossplane, because Crossplane teaches Kubernetes to pretty much manage everything else because of its extendability. And the nice thing about Crossplane, it doesn't only allow us to manage everything, we can also compose these resources into higher level abstractions, and that allows us to give it to our developers for self-service provisioning. So this is how it looks in our example. So we have a platform, there's many moving parts, and the nice thing is we can all abstract that all the way behind a simple interface. So again, we can take granular resources even from multiple clouds. In the example of a GKE cluster, there's many moving parts, like a node pool, network, subnetwork, and so on. And we can offer that as a single cluster abstraction with a very simple API with limited configs, so developers can, in a self-service, go and claim and create a cluster. So we can hide it all, and while we're doing so, we can also include our policy guardrails and all of the best practices which we figured out, so that people don't need to repeat these all over again. And all this with native Kubernetes API. So everyone who is already familiar with it will be very comfortable using it, and it integrates well with all the GitOps tools or even like manual tools like kubectl. And the best part, like for consumers, there's no code required. It's all just a simple YAML. So here's the whole stack. At the bottom, we have Kubernetes running workloads, ingress and RBACs with the Kubernetes runtime. On top of that, we have the persistence layer with CRDs, OpenAPI, and etcd. And then there comes a controller runtime, which emits events, watches for them, accepts requests, and issues the reconciliation. And there comes Crossplane, which extends this model, which allows us to put our own APIs into the picture. And then at the very last, we have our custom logics, which runs into controller, and we will talk in a second about how that actually looks like. So the basics of Crossplane. Let's go very quickly over it. At the very low level, we have like managed resources. That's just an object under the control of Crossplane. It can be pretty much anything that exposes an API. So this is how it looks like as a simple example of an S3 bucket. On the left-hand side, you see like the YAML, how it would look like in the cluster. On the right side, you see how it would look like on the cloud provider. And like I said, Kubernetes also emits events. So if we describe that object, we will see the actual status and what happened with it. In this case, it just successfully created an external resource. That's nice, exactly what we want. So here's the reconciliation loop in one picture. On the left side, you have the YAML. On the right side, you see the cloud provider. And in the middle is the whole reconciliation loop. So if anything changes on either of both ends, Crossplane will kick in, reconcile it, and achieve the desired state from what we defined. So if you're going to change your bucket or someone with admin access who's not supposed to do it, the next reconciliation loop, Crossplane will just kick in and roll it back to what we want. Exactly the stability which we're looking for. So the managed resources, they don't just fall out of the sky. So we need to get them somehow in the cluster, and we need to get the controllers. That's what providers does. They also install the CRDs to the cluster, and they are responsible for that reconciliation to a loop we talked about. There's a bunch of providers. You can check them out. Where you can check them out? For example, on Upbound Marketplace, there's pretty much a provider for almost anything these days, and I really advise you to have a look there. So when we talk to external systems, authentication is always a thing. So just a brief note that you can use static credentials even though you shouldn't. So for all the major providers, for all the major cloud platforms, you can also use assumed identities. So there's no static credentials required. If you're running an Upbound, you can also use Upbound OIDC to integrate with any system. So whenever there's credentials and identities in play, the question of multi-tenancy comes up. So how do you do that with Crossplane? So in V2, everything except for the claims, which is the consumer part of your API, is cluster scoped. So to achieve some soft kind of multi-tenancy, you can actually build provider configs in your composition. So you have some way of selecting different tenants. But it's quite hard to do, and if you need like a full isolation, multi-cluster is in Crossplane V1 your only way to go if you really need this hard isolation. But don't you worry, because Crossplane V2 is coming and it's supposed to fix all that if you don't like it. And as a cherry on top, you also get direct composition of local cluster resources. If someone used already Crossplane before, you might be familiar with the problem that you need to use provider Kubernetes, which sometimes feels like a big overhead. And V2, this is no longer the case. So let's start with compositions, because now we have our managed resources, but it's still not enough to serve a simple abstraction. So that's where the composition comes into play. So it takes these managed resources and bundles them into single objects, and it does that by running functions. More on that later. So now we compose our resources, but we still need to define our interface. So what is it our developers or our consumers in general can actually interface with when they create such an object? And that's what we call an XRD, or a Composite Resource Definition. And once you create that, your cluster will receive a CRD, so it's available as a normal Kubernetes object. This is how a composition looks like in YAML. So you see like a function pipeline at the bottom, and you see like the XRD API version, which is your API which you write. Can be the name of your company or whatever, and of course it's versioned. This is how the Composite Resource Definition looks like. So you have simple open API schema and also your custom API group. So because everyone likes to package a thing so that we have an immutable artifact which we can test and propagate for all the stages, Crossplane also offers this packaging for your compositions, or in fact you can even package multiple compositions, and that's what we call a configuration. It's distributed as an OCI image like everything else in Crossplane, and that's why we have a package manager where you can declaratively manage these packages, and it also allows you to define dependencies between them, and it will all manage that under the hood for you by resolving these dependencies and installing the required components in your cluster. Finally, we made it. We have something to consume. So we built a small PostgreSDB hiding the instance, the parameters, security groups, and all that behind a simple interface for your consumers. This is how it looks like. Very simple case. You have no SQL database with just one parameter, size small. So pretty easy. Everyone can create that. And you can expose that to your developers in a Helm chart as just a YAML via GitOps, via kubectl, whatever you decide. So now we talked about the bigger picture, but we still didn't figure out like how we actually compose this stuff. That's when we enter functions. It's pretty much just a pipeline of single units, which are like the functions, and it's supposed to provide you a sweet spot between writing no code and writing a full controller, because as we had with the managed resources, we need actually some mechanism to reconcile them, and that's what the composition engine is for. And it works pretty simple because it starts with nothing, and every function either adds something to the YAML or removes something to the YAML, and at the end you have a collection of objects enriched with all the business logic or whatever you need to customize for your case. So you don't have to write any code to use functions. There are reusable functions out there, a lot of them in fact. So you can, if you need high customization, you can also just write your custom function from scratch. But just to see some examples that you don't need to write everything from scratch, here's how it looks like if you, for example, with Helm templating, create a list of access keys. Or what we heavily use at Upbound, KCL, which is Kubernetes configuration language, pretty new, but sort of a sweet spot between being declarative but still offering some escape hatches for doing it imperative stuff. So here we just create a list of EC2 instances for regions. Or if you want to go full-fledged code, you can just write your whole function yourself, for example in Go or in Python. Actually, there's many methods available, but it's up to you to pick your favorite language of choice. So we talked about the consumer a lot. What about you as a cluster operator? Maybe you want to have a single place to switch locations, or maybe like have a list of tags or whatever it is you want to configure on a global level. That's why I have environment configs. So they serve as some sort of an admin interface for defining cluster-wide things. It's pretty much just a glorified config map, and you can use it in your compositions. How? Well, you most probably guessed it, by functions. And here's a simple example. So it's a two-step pipeline. In the first step, we actually just fetch the environment configs by name in this case, and then we pass it to the function Go templating for your consumption. So there's also claim communication. So it was a long-standing problem in Crossplane that when your user creates a claim and something goes wrong, they pretty much have no idea what went wrong, because there's a pretty hard separation of concerns at play here. So that's why there now exists a method to actually forward these conditions to your user. And because we don't want to just simply forward everything, there is a method of actually selecting what you want to surface to the user. So this is how it looks like. So there's an own function, the status transformer, which you can use to select what you want to forward and then expose it to the claim. If you use one of the functions mentioned here, and I think some others also offer it, you can also use it in your functions directly as some custom API type, like you see here. And yeah, it's pretty handy for people who work with it. It's usually a big problem, and now that's pretty much solved. Just as a side note, Crossplane and providers also, of course, offer a metrics endpoint, which you can scrape and integrate with your favorite observability tools. Just some dashboards here as an example. Okay, so now we went very quickly through how to actually build the stuff. But as you know, building is not enough. We also need testing and validation. So how do we do that? So in the first step, you don't want to go and build a GKE cluster and just apply it to see if it works. That would take way too much time. So as a first step in our feedback loop, we have a render command, which actually executes this function pipeline. It takes your composite resource or your claim as an input, and it will show you which YAML will be applied to the cluster. You can see it at the bottom. It's a Crossplane render command, and it's very handy to get a quick feedback loop. However, what it doesn't do is validate the input. So, like, first of all, we can also use all of these extra resources, like maybe other Crossplane claims or the environment configs we talked about, or pretty much any object in the cluster. So you can reference them all in your composition pipeline, but with the render command, you can actually mock them and see what happens. But you still don't know if that YAML which you render actually conforms with the CRDs you have in your cluster. There might be like some false as a string, or you might have true as an annotation, and you won't be able to see that unless you actually run the validate command. And it's built in a very simple way, so you just render and pipe the output to the validate command, and it will either fail or succeed, and you will see this in a second in the demo. There you go, Yury. Kick us off with the demo, please.
Thanks a lot, Tobias. So, today my main mission is to run live demos almost at 9 a.m., so please wish me luck. All right. Is it visible, or should I enlarge the font? Is it good? The back? Good. Thank you. So first demo is for render. Who's using Crossplane render on a regular basis? Not much hands? You should. Let's check it out. So what we have as an input, like as material for Crossplane materials that we're working with. We have a composition. It's some kind of Go templating, right? It implements some logic. We have an XR as a parameterization, like as a main composite example. So simple X tenant, that would be actually like an input to our composition. So pretty standard Crossplane stuff. And what we want to do is execute our composition logic and see how the desired state of composite resource look like. So we can just run Crossplane render command. I'm just piping it to YQ for the colors, and we can see that our composite resource is around, and the map of desired resource is there. So composition logic worked as expected. So we can do like a testing stuff, like get a quick developer feedback, run it again after the modification of composite resource spec, and see like our loop, our in a composition actually works. So when we modify the spec, it provides a different result. So all good. It's a fast feedback. You notice that we do not operating any Kubernetes cluster yet, so it's totally local and super fast. Obviously, we can, during the development, we can do like, some mistakes. And let's say I made a typo during the wrench loop, and I reran the render again, and I can quickly get a feedback from a system, right, that I made a mistake. So I can quickly fix it. So no need to deploy to a real cluster, and it's good, and it's fast. Now, for kind of advanced rendering scenario. So what we just seen, it was like a first reconciliation loop, right? So if we quickly check our composition, we have the main loops that iterating our X tenant spec and create some namespaces, right? And we also have this part that populates the XR status with runtime data. So what we want here is actually populate some runtime IDs, that is pretty frequent case, to the XR status. So if you look at standard render without observed, I have it in this make target. With render no observed first. Yeah, so just standard render command, right? And you'll see that our logic, it's kind of work, but it's null because we don't have any data. And how to mock it out? So now, again, we are not operating in a real cluster, and we want to mock out the observed resource state. So we have some observed directory where we have a snapshot of observed resources. So that's how you can mock out like a second reconciliation loop when Crossplane already observes some existing resources in the system, and actually read the data from them. So now, when we render with observed, and we can notice that it's pretty much the same command. We just use the observed resources and point it to that directory that contains the mocks. Now it properly read the data and populated the extended composite resource status. So we can also test the advanced logic with advanced mocks in total isolation. So that is also powerful. And on top of that, we can also create some validation. So similar scenario, similar kind of composition. In this case, it will be actually X network, and this kind of XR. So it's like it's an example of our configuration AWS network, one of our reference platforms prepared for the demo, and we can run a validate command. How validation command will look like? It's an actual render with a pipe to beta validate schemas. And in schemas directory, we just have our configuration reference, and the machinery will pull the schemas for configuration itself and for dependencies like provider AWS EC2, right? So here we see that it managed to catch actually a couple of errors. And let's check them out. So it's schema validation for the main resource spec. Okay, that's good. And we can actually fix them quickly because I prepared the fix for the demo. So we're just stating the missing API fields, right? We're running the validation, and see how it goes. Again, rendering, piping to validation, and we see that there is no failures. So good. Again, without any deployment, any end-to-end deployment to any cluster, we are getting good feedback from a system. We're getting confidence, and as you can imagine, you can put this stuff into any kind of pipeline, run them locally. You can use them like in different scenarios. Now, as you see the pattern, like, you know, we can render stuff, so we probably can do even more interesting stuff with the render resource of arrays, array of resources, yeah, like a render YAML. So we can evaluate it. So what we can do is actually write some form of kind of unit test against the render stream. So what we did for this demo, so it's a slightly different example. So it's a Azure network, yet another reference platform that we have. Simple XR, simple composition, still old school Passion transforms that is cool for the demos. And we want to validate the logic, right, against the render YAML. So I wrote some tests in KCL, so I'm reading the render file, and I'm creating some set of isolated unit tests, checking the fields, right, in total isolation. So how it would work? I would run render test. We have make targets for everything that moves. So it creates the render file, and it runs the KCL-based test suite against it. So render YAML, again, nothing special. It's just output of the command with input of XR and a composition. And this is our passing test suite. So what we can do with that is actually pretty interesting test-driven development for infrastructure, right? So if I open my test suite again, I have a prepared test suite for the new service endpoint. I want to extend my composition, and a TDD flow I first write in test, and it's supposed to be failing test, right? Because the actual Crossplane code, composition code is not yet implemented. Let's run render test again. It should fail because no code around. And now we can actually implement the code in composition, and in our case it will be super trivial, like a demo style code. We just extend the service endpoints array with the new values that we expect, right? So now it's our functional code, we're updating it, save the file, running test again, and we close TDD loop, right? So we can, with that TDD approach, we can build like a naturally, organically growing regression test suites in a total isolation, getting a fast feedback, and have a pretty good platform development experience. So that's it for this demo. Tobias?
Thank you so much, Yury. So fast feedback loops are good, but they don't capture the real world, so you also will need to have some sort of an E2E test. That's why at Upbound we created Uptest. So it's a low-code E2E test automation framework. So you just provided examples. That's all you need to do. You don't need to write your custom logic, and it can be used to test Crossplane providers or Crossplane configurations. So it was originally developed by us to speed up development velocity and to serve the production of our official providers, but we eventually open sourced it and donated it to CNCF. There's also other testing frameworks available, so a huge shout out to our folks at Deutsche Bahn and Swisscom. I don't have time to go there in detail, but you can check it out after the presentation. And going back to Uptest, how does it work? So it's a CRUD-like testing flow. So we will actually apply the objects to the cluster, see if everything is healthy. We'll try to do an update, see again if everything is healthy. Optionally, we can also try to drop some resources and import them back and delete them. And the last two steps can also be, actually update, import, and delete can be skipped if you don't like them. And actually, we're going to move right into the next demo.
Yeah, let's go for it.
Please cross your fingers because it's a live demo with internet access. So
yeah, it's end-to-end. Now we're going real with end-to-end test and actual APIs. So it's the same Azure network for which we just wrote an isolated unit test. And now, we want to actually run the end-to-end one and check if it actually works on the real cloud provider side. So, if we wouldn't have any automation, we would apply the X network XR on a real cluster and see how it goes and to perform some manual validation. Luckily, we have Uptest, and we can just run end-to-end, and I will tell Uptest not to delete stuff because we will need it a little bit later. But so I'm running it, and Uptest automation will create first a local client cluster for me in fully automated manner and install Crossplane there. So I don't need to care about this kind of basics for bootstrapping environment. So everything is done for me in automated manner. After the Crossplane installation, it's going to do some magic with a dev sidecar. Why we are doing it is actually we are creating a dev sidecar container next to Crossplane deployment, and we injecting package cache our Crossplane configuration. So we are not doing the round trip like a push configuration and pull configuration. We're directly injecting into the test local cluster, and this way we can test the local code even without committing to Git, which is pretty handy. Now we are running setup script, and a setup script basically waits for configuration, Crossplane configuration to be ready. So we'll clear this one, and we can, in a parallel terminal, we can look around what is happening in the cluster. So now our configuration Azure Network under test is installed, not yet healthy. Our automation is waiting for next stage. With the configuration, we obviously pulling the dependency, right? So providers are getting pulled from the internet, so it will take some time, hopefully not too long. And after that, the test automation should proceed with application of resources. So now it applies this network XR against the code under test in an end-to-end manner. So we are going to get the actual feedback from Crossplane beta trace that is embedded in a framework and see what is happening. So it's effectively what is showing to us. It's a beta trace. Who's using beta trace on a regular basis? Nice. If not, you should. It's very handy because you can actually see X network and all the composed resources and its current status. So I'm doing parallel check just for the demo, and you don't have to do it because you can just wait and relax while Uptest is doing things for you. And I think for the sake of time, we will leave it around and we'll check the status afterwards. And back to the slides.
Thank you. So Last but not least, let's talk a little bit about disaster recovery. So you might lose your cluster, and what you can do, so you can use traditional backup solutions like Velero, but what we recommend is for mission-critical resources, use a deletion policy of orphan or make use of the more granular management policies. And on top of that, you should actually use, whenever possible, a predictable identifier for Crossplane IO external name annotation. This is what Crossplane uses to identify your managed resources in the external system, and if you use that, you can actually drop your whole cluster, and once you bring it back, Crossplane will just discover these resources, import them, and there's nothing to do for you. It just will work after you drop the cluster. Oh, we go actually back to the demo, because hopefully we will see some disaster recovery there.
Let's see. So let's see if the Uptest is ready. Oh, unfortunately not yet. So we are still waiting for the last subnet resource to be ready. So we blame Azure here. And we need something. So now all the Composite Resource external cloud resources are ready. We're just waiting for the XR status to pick it up. It should be pretty quick. And while we are doing it, from a disaster recovery standpoint, I will quickly explain what we're doing with a predictable identifier. So if the cloud provider allows to perform this predictable identifier thing, it is highly recommended to do it, because here in this simple patch, what we are doing is we are propagating the stable ID to the metadata name of the resource, and also Crossplane IO external name. If you work with Crossplane, you know that Crossplane IO special annotation is something that tells Crossplane to, if it exists and set on a Composite resource, it will tell Crossplane to first import and try to import external resource, and if it doesn't exist, then create it, right? So with a predictable identifier. And this way, we basically can make our composition, and I'm attaching this patch for every Composite resource, right? We can make this composition smart enough to re-import resources with a stable identifiers, meaning that we don't need a backup, right? We just can instantiate the XR with the same identifier again, and Crossplane will take over the control over the resources. So super quick disaster recovery demo. Our Uptest worked, right? Everything is applied. As you remember, we didn't delete it intentionally. We skipped the deletion step during the invocation, and now we can make a Crossplane beta trace. Everything is ready, and now we emulate the disaster. We are going to.
Sorry to cut you short, but we have 7 questions, and it would be great if you could get to some of them. So
yeah, sure.
So the first question is, well, obvious about the comparison with Terraform.
Yeah. In comparison with Terraform. Yeah, so Crossplane is a control plane, right? Terraform is just CLI, so it's the main difference. Crossplane enables reconciliation drift. The maximum analogy that you can do with Terraform is put a CLI somewhere in a CI pipeline. That is usually brittle. So Crossplane is the next level control plane loop with automated configuration drift out of the box, and with all Crossplane integration, Kubernetes integration in all community.
Is there a Terraform controller so that you could use already existing modules?
Yeah, that's a great question. We have a provider Terraform and provider OpenTofu, and it's relatively frequent way how our customers are onboarding quickly to Crossplane world. And what we usually do, we create an abstraction, an XRD, like a stable contract in front of provider Terraform composition, and this enables a platform engineer to evolve behind the API line and migrate eventually to a full Crossplane native providers.
And the next one, highest voted. Is it possible to configure some quota so developers won't deploy 100 databases by accident?
So yes, you can actually use Kubernetes native quotas for that. So that's not even, you don't even need to go into Crossplane.
Is there already a mechanism for password generation that will not regenerate the password during the next reconciliation? And regards to Viktor Farcic.
So usually, like you would create a resource, for example, like an RDS instance or something, and the cloud provider would actually generate that password. So usually Crossplane doesn't generate these passwords. So ideally, you would generate it yourself and put it somewhere in like Secrets Manager or Vault or something, and then you would use something like External Secrets Operator to actually fetch that and use it in your resources directly. So you wouldn't necessarily create it with Crossplane itself.
Yeah, I did it without even external controller. Like it's important that it's not regenerating on each reconciliation loop, so you can put somewhere like environment config, for example, and then read from it on the next one if it already like field exists.
How many controllers do I need? Can I have it running tens of them?
It depends on complexity of your composition, right? So we have a family providers, and it depends how many service scope providers you are running, like from how many cloud providers, etc. So that's pretty much depends on your use case.
This is an interesting one. Is Crossplane more suitable for managing cloud resources? What about managing on-premise, like VMware, bare metal?
So as long as it exposes an API and it supports a CRUD-like workflow, you can manage everything with it. Like we use it internally to manage GitHub, for example. You can talk to your hypervisor if you have the right provider and it implements these functions. So that should be no issue.
And,
yeah, for bare metal, we have a blog post where we're using Cluster API. So we're working Cluster API with the Crossplane abstraction and basically running bare metal OpenStack. So that's all possible.
Perfect. What's the planned GA timeframe for Crossplane version 2?
I think we cannot disclose anything like that yet.
Not yet. Yeah, we cannot share exact date, but yeah.
I didn't think you would, but anyway, it's worth asking. Is Crossplane managing state of deployment anyhow? If so, how, please?
So you can use provider Kubernetes at the moment in Crossplane v2. You're talking about Kubernetes deployments, like just deployment objects?
I didn't ask the question, so whoever asked the question.
Okay. Yeah, so you can use it to use provider Kubernetes at the moment to manage any Kubernetes object, like whatever you want, also deployments. In the future that will change, so you don't need to provider Kubernetes. If you want to manage an external cluster, you can still use it, but yeah, pretty much there's no limits to it. What do you want to modify?
The deployment of whatever infrastructure. I'm comparing to Terraform. If you are deploying with Terraform whatever infrastructure, and it is finished, if you want to modify it somehow, add new node, whatever, you are adding that to existing state of the deployment. I'm asking this, how is going to be deployed.
Well, you have your YAML, and you would just add whatever you want to modify there to the YAML, and then it would be applied instantly. And if you change something, like you remove a node, and next time Crossplane sees it, we'll just add it back again.
Okay, so Crossplane basically is making their own checks of existing state.
Exactly. It's constantly, it's by default, running every minute, and there's even some thoughts behind of in the future, like to actually react on events, but at the moment it's just like your configurable reconciliation interval where it will check that and just roll it back. Yeah.
Perfect. We are out of time and luckily out of questions too. Thank you very much. It was a very interesting presentation.
Thank you so much.
Thank you so much. Great.